Hey everyone, and welcome. Let's be honest, we are absolutely drowning in data, right? Sports stats, sales figures, website clicks, it's just everywhere. And most of the time, it just feels like a whole lot of noise. So the big question is, how do we get from that total chaos to some real clarity? Well, that's exactly what we're going to dive into. The best way to think about this is like cooking. Seriously, all that raw data you have, that's just your ingredients. A pile of flour, some eggs, a little bit of this and that. Not much on their own. But data analysis, that's the recipe. It's the technique that transforms those raw ingredients into a finished dish, a clear, understandable, and often totally surprising story. So let's get into the kitchen and walk through that recipe together. So here's our game plan for today. First, we've got to get to know our ingredients. What kind of data are we even dealing with? Then it's time for the prep work, organizing everything and summarizing it. After that, we're going to make it look good by visualizing the data story. And for the final course, we'll connect the dots, find some hidden relationships, and maybe even predict the future. Ready? Let's do it. All right, first things first. Any good chef will tell you you have to understand your ingredients before you even think about cooking. Is it a vegetable or a fruit? Is it salty or sweet? Well, the exact same principle applies to data. We got to know what we're working with. The first and biggest split you need to know is between quantitative and qualitative data. Quantitative is the easy one. It's numbers, things you can measure or count. The how much or how many. Think about height, temperature, or price. Qualitative, on the other hand, is descriptive. It's about the what kind. Think blood type, car models, or your favorite movie. It's about categories, not numbers. And we can get even more specific here. Even our number-based ingredients have different, let's call them flavors. With an interval scale, like temperature, the difference between 10 and 20 degrees is the exact same as the difference between 20 and 30. The intervals are consistent. But then you have a ratio scale, like weight. Here, the ratios themselves are meaningful. 20 kilograms isn't just 10 more than 10, it's literally twice as heavy. That's a really key distinction. And the same thing goes for our categorical data. Something on a nominal scale is just a label. Think blood types, A, B, O. There's no ranking. One isn't better than the other. But with an ordinal scale, the order is everything. Think about grades, A, B, C, D. An A is definitely better than a B. But here's the catch. The gap in knowledge between an A and a B might be tiny, while the gap between a C and a D is huge. The order matters, but the space between them doesn't. Okay, so we know our ingredients. Now it's time for the prep work. This is where we take a whole mess of information, like a chaotic spreadsheet, and we try to understand its essential flavor by boiling it all down to just a single representative number. Let's make this real. Imagine you have the daily high temperature for an entire week. If someone asks you, so, how was the weather last week? You're not going to list all 7 numbers, right? No way. You're going to summarize it. But how? How do you pick that one perfect number? This is where our measures of central tendency come in. So we've got 3 main tools in our kit for this. First up is the one everybody knows from school, the mean. Yep, that's just the fancy name for the good old average. You know the drill, add them all up, divide by how many there are, and boom, you've got a solid number that gives you a sense of the data's center. It's a great place to start. But what if one day was a crazy outlier, like a record-breaking heat wave? That would pull the average way, way up and make it kind of misleading. And that's exactly why we have the median. All you do is line up all your numbers from smallest to biggest and pick the one that's smack dab in the middle. It's the true middle ground, and it doesn't get pushed around by those extreme values. And our third tool is the mode. This one's super simple. What if you just want to know what was most typical? What value showed up the most often? That's the mode. It's not about the average, not about the middle. It's just about what's most popular or common. 3 tools, 3 different ways of telling the story. And check this out. This is where it gets really interesting. Look at this real week of temperatures in Tokyo. The mean, the average, was about 12.6 degrees. Okay, but the median, our middle value, was a little cooler at 12.1. And the mode, the most common temperature that week, was only 10.4. So which one is the right answer? Well, that's the trick. None of them. They're all correct. They just tell a slightly different story about what that week was really like. A single number is a great start, but it really doesn't tell the whole story. Is all the data clustered tightly around that average, or is it spread all over the place? To really understand that, we need to go beyond one number. We need to visualize it. We need to actually see the shape of our data. The key tool for this is called standard deviation. Now, I know that sounds super technical, but the concept is actually pretty simple. It's just a single number that tells you how spread out your data is. A small standard deviation means all your data points are huddled together really tightly around the average. A large one means they're scattered all over the map. That's it. Another great way to see the spread is with quartiles. Imagine lining up all your data from smallest to largest again. Now, just make 3 cuts that divide that line into 4 equal chunks. Those cuts are your quartiles. You've got the 25% mark, the 50% mark, which, hey, that's just our median again, and the 75% mark. And this all comes together in this brilliant little visual called a box-and-whisker plot. You take those 5 key numbers, your minimum, the 3 quartiles, and your maximum. The box in the middle shows you where the center 50% of your data is living, and then the whiskers stretch out to show you the full range, from the lowest value to the highest. It's like a complete snapshot of your data's distribution, all in one simple chart. Now we get to the really exciting part. We've organized our data, we've summarized it, we've even visualized it. Now we can start asking the bigger questions. Can we find relationships between different things? Can we use the patterns of the past to actually predict the future? Our main tool for finding these relationships is the scatter plot. The idea is super simple. You take 2 different variables, say the number of hours someone studies and their final exam score, and you plot them as a single point on a graph. Once you've plotted all your data points, you just step back and look. Do you see a pattern emerge from that cloud of dots? That pattern is the relationship we're looking for. If the dots on your scatter plot seem to form a line that goes up from left to right, you've got a positive correlation. This just means that as one variable goes up, the other one tends to go up as well. And you can probably guess, if the dots trend downwards from left to right, that's a negative correlation. As one variable increases, the other one tends to decrease. But this brings us to what might be the single most important rule in all of data analysis. I mean it, this is a big one. Just because 2 things are related, it does not mean that one causes the other. A relationship is not a reason. This is a fantastic example. It's totally true that as temperatures rise, sales of shaved ice go up. It's also true that as temperatures rise, the number of heat stroke cases goes up. So shaved ice sales and heat stroke are definitely correlated. But does eating shaved ice cause heat stroke? Of course not. That's absurd. There's a third factor, the hot weather itself, that's causing both things. This is a crucial distinction you always have to remember. So once we've found a meaningful correlation, we can take it one step further with something called regression analysis. This is really just a method that mathematically finds the line of best fit that cuts right through the middle of the dots on our scatter plot. That line basically becomes our guide. We can use it to make educated predictions about the future. It's like finding the perfect recipe to forecast what might happen next. And there you have it. We've gone all the way from a chaotic sea of raw ingredients to a clear recipe for finding patterns and even making predictions. We've learned the basic language of data. And that's really what this is. It's a new language for understanding the world more clearly. So the only question left is, now that you know the basics, what stories will you uncover?